Okay, here's your 5, section 1, perpendiculars and bisectors. First, before we go any further with your arms, show me perpendicular. Let me see. With your mouth, shout out what kind of angles they create. Perfect, 90-degree angles, they're right angles. Okay, let's jump into it. Very first thing, perpendicular bisector, is draw an arrow to this. Draw an arrow to this. If you break it up into those words, I'm hoping that a visual will pop up in your head. First, it's got to pass 2 tests. First, it has to pass the perpendicular test. Second, it has to pass the bisector test. So perpendicular bisector, it can be a line, it can be a ray, it can be a segment, but let's draw a picture of what it will look like. So first, let's start with just a regular segment. So endpoint to endpoint. Okay, let's create a perpendicular bisector. Let's make it a line. So what I'm going to draw in purple is the perpendicular bisector. That's not too bad. Make it a line. So perpendicular bisector is this. Okay, but perpendicular bisector, there's 2 words. It has to pass 2 tests. First test is the perpendicular test. What has to be in that picture in order for it to be a perpendicular bisector? 90 degrees. Perfect. You've got to have your 90-degree angle. This has to cut the segment at a 90-degree angle. It's the first test. So right over here in your notes, just remind yourself, 90 degrees. Okay, the second test is that it has to be a bisector. Do you remember what bisect means? Perfect. Cut into 2 equal pieces. Cut in half. So right here, remind yourself, bisector is cut in half. So the first test, it had to have the 90-degree angle. The second test, it has to have this piece is congruent to this piece. Must have that. Okay, a reminder. This purple perpendicular bisector, guys, could it have been a segment, just a piece cutting it? Sure could have. Could it have been like a ray? So it starts and goes up. Yes, perpendicular bisectors. It can be whatever as long as it passes those 2 tests. It's perpendicular and it's a bisector. We're going to create them tomorrow. I'm real excited. Okay, this next part, equidistant from 2 points. Well, that's like 2-part word. What do you think equidistant means? Right? Just means equal distance. So write that in there. Equal distance. And I'm going to jump the gun and show you something about perpendicular bisectors. So that purple in the picture is the perpendicular bisector. If I put a point on the perpendicular bisector, literally has to be on it, something happens. That perpendicular bisector, going from this point that's on the perpendicular bisector to here, to the end point, and then going from this exact same point to this other end point, something happens with those 2 blue segments. Any guesses? They are always equal, always equal. They're always equidistant. This piece will always equal this piece, as long as that starting red dot is somewhere on the perpendicular bisector. Always be congruent. So that's a use of equidistant. Okay, this one, distance from a point to a line. I feel like that's pretty self-explanatory, isn't it? So maybe let's just draw a picture. Let's draw a point and a line. Here's a point. Here's a line. This would be the distance. Yeah? Pretty basic vocab. We would just measure the distance between it. So again, tomorrow we're going to bust out the rulers and start constructing stuff. Okay, this one, reminder, what does equidistant mean? Equal distance, same distance. Well, it says equidistant from 2 lines. So can I just use this picture and maybe eyeball it, draw another line. Maybe this point is equidistant from both lines. These 2 distances equal each other. Well, does that make sense? Okay. All right, the vocab is done. Now we're going to jump right into our theorems, but I already gave you a heads up on them. So let's make sure we understand. So the bottom of this front page, chapter 5, section 1. Okay, so this is the perpendicular bisector. So it's saying check if the point's on the perpendicular bisector, stop. Look at your picture. Which point is on the perpendicular bisector? Perfect. So they're talking about this point C. Then it's equidistance from the endpoint. Stop. Shout it out. Which one are the endpoints? So here's endpoint A. and point B. So it's saying since this dot is on this purple perpendicular bisector, wait, check, are you sure it's a perpendicular bisector? Remember 2 tests. Does it pass the first test? Yes, there's the perpendicular sign. Does it pass the second test? Yes, we've got the 2 congruent pieces. So like I warned you, from the blue to the red, it's going to be the same from the blue to the red, no matter where you're at. Pretty convenient. Okay, give me a thumbs up vote. Thumbs up, I understand that. Does that make sense to you? How's these? I'm just trusting you. Damn, I don't get that concept. Let me see your thumbs. How you feel about the concept? Okay, the next theorem is this same thing, only backwards. It's the converse. Remember how we learned about converse? You just switch the 2. So same thing, but it's saying, what if you start with, you know that from this point to these points, it's the same distance. And you just go backwards, okay? Then that means the point has to be on the perpendicular bisector, that perpendicular bisector. So this is more focused on, now we know this is on the perpendicular bisector. How you feel about that concept? Thumbs up. How's these down? Again, it's just backwards. Start with the point and then go. Okay. Okay, pictures galore in this chapter, so get ready to draw and put symbols on here. So in the diagram shown, BE is the perpendicular bisector. Okay, perfect. Guys, honestly, with your pencils, make it a little more obvious. This is our purple perpendicular bisector. Passes the first test. Check, check. There's perpendicular sign. So we need something else on there. Second test, we need that it's bisecting it, right? Let's put those symbols on there. They'll probably come in handy when we do what it's asking. Okay. Oh, yeah, convenient. Look, letter A. What segment lengths are equal? We just put our symbols on there. Which ones are equal? Perfect. I like that you said AE and CE. Perfect. Okay. Well, then letter B says AP is congruent to CP. So stop there and put your symbols on there. AP, this, is congruent to CP, this. Oh, so if those 2 are congruent, what's going to happen to P? Okay, this would be the midpoint right here, right? Because that piece is congruent to that piece. Look at that perpendicular bisector. Will that purple perpendicular bisector eventually touch that? Okay, I agree. So if we extended this line, it's eventually going to touch it. But since we know that this piece is congruent to that piece, does that ensure that P is on the perpendicular bisector? Yes. That's what it's saying about P. So about point P, we can say it's on the perpendicular bisector. This is very similar to your homework assignment tonight. You gotta look at a picture and decide what you can conclude about the picture. So first thing we concluded, A is congruent to CE. Second thing, we can say point P is on the perpendicular bisector because those 2 pieces are equal. Whew. All right, I think angle bisectors are, yep, we've done angle bisectors. So let's stretch it a little bit. So angle bisector, check your picture. It's taking one big angle. So we've got this big blue angle. Angle bisector always cuts an angle right down the middle. So this piece is congruent to this piece. Hands in there. Do you remember talking about angle bisectors? Yeah? It's on our word wall. It's been up there forever. Okay, but the new thing that we're adding today is if you take a point, so on this picture, point D is on the angle bisector. Will you nod your heads? Does that make sense? Point D is on the angle bisector. If there's a point on the angle bisector, if you go from that point back to the original angle at a 90-degree angle, this point back to this side of the angle at a 90-degree angle, those pieces will be equal. Crazy, huh? Super cool. So DB will equal DC as long as that point is on the angle bisector. And I think the next one is just, yep, the converse of it. So this one is saying, what if you know that there's this random point here, going back to the angle, 90 degrees, it's congruent to this one, 90 degrees. Then we can say that D is on the angle bisector. D's on the angle bisector, if that's on the angle bisector, those two have to be congruent. It's like the same stuff all together said backwards. Again, it's converse. Converse is the switch, the flip of the if then. Whew, flying. Okay, flip the page. All right, let's go to the bottom of the next page. Again, this is very similar to your homework assignment. So let's look at it. Try looking at it your own and see what you can conclude. I want to see anything that you can conclude. Okay, start with what they give you. So it says in the diagram, PQ is congruent to RQ. So stop and draw on your picture. Put this on there. PQ congruent to RQ. How many of you did that? Perfect. All right, then it says what conclusion can you make about Q? So just that point right there, Colton, what do you think?
What is the angle bisector?
Sector? Not quite. Yeah, perfect, Colton. That's so. I'm gonna type it in. Say that point Q. Their bisector. All right. Okay. Does it make sense? Point Q is gonna have because if those two are congruent, remember how we talked about that theorem? We're gonna say if this from here to that point, if they're congruent, this has to be on the perpendicular bisector. Yeah? Okay, well then it says right here, can you conclude that S is on the perpendicular bisector of PR? I kind of don't like this question. Can I show you why? If you look at the picture, if you just draw a line down from Q to S, we just said that Q is on the perpendicular bisector, right? Well, technically, here's Q. If we draw a line down, don't you agree we'll get to S? So I feel like the picture is misleading. Because from the picture I'd say, yeah, because we can draw a line from Q to S, it would have to be on the perpendicular bisector. However, in order to be absolutely safe, we would need to know that this is congruent to this. Do we know that just from what's given? No, we don't. So that's a question that I would absolutely not ask on a quiz or a test because that's misleading. Okay, biggest thing on this one, we know for sure that Q is on the perpendicular bisector, like we typed in. Okay, next one. Oh, I hope you guys did okay on this one. In the diagram, D is on the bisector. So check, if it's on the bisector, we could draw in, this is congruent to this. Okay, so what is DC? Okay, show me with your finger. What do you think DC measures? Hold up that many fingers, let me see. Yes. Yes, you're checking each other out. Perfect. Because look, from D to A, it's what?
6.
So from D to C would have to be 6. Be confident, that was perfect. Okay, let's definitely work together.